Hello there, welcome back to Differential Questions by Alexander. All right, so today we're going to talk about variation of parameters. It's a very short topic, but actually very powerful. All right, so the type of equation is going to be this type. And now the big difference between what we're covering today and the ones on the previous videos is that the A, the B, and the C can be functions now. In the last few videos, we had the A, B, and C to be just numbers. And so now we're saying that now we wanted to be able to deal with functions that are A, B, and C that can be functions. And so I'm going to give you the outline of the method just very briefly. I'll try to make it 2 steps. And then I want to give you 2 examples. All right, so the first step is that your differential equation, you first want to divide by the A because in front of the y double prime, you don't want to have this A. And so we're going to divide everywhere by the A function. And so we get this, but we're going to rewrite this one more time. And then we eventually get to this thing where we have the P, the Q, and the F, where the P is the first parentheses, the Q is the second parentheses, and the C divided by the A. And F, oh, actually, I little typo here. So this is G divided by A. And that is what the F is, okay? So that's the first thing that we want to do. We want to get the differential equation into the standard form, which is the last red square bracket box that we have. All right, so now the second step is going to be the following. Now that you have the standard form of the equation, now you want to look at the homogeneous equation, associated homogeneous equation, and now you want to find the complementary solution. Okay, so the solution to the homogeneous equation, we have to find that. Okay, and so now after you do that, once you have the y1 and the y2 functions, there's a few things that we now have to calculate. So it gets a little bit more complicated, but it's just a calculation that we can do. And I'll try to put this in color. So just know that we have 3 different things to calculate. And the first one actually is the Wronskian of the y1 and the y2. And then the other ones are going to be, so w1 is going to be the same Wronskian, except that we are replacing the first column with a 0 f. And then the f is g divided by the a. So making the correction here again, g divided by a. And now the w2 is the same Wronskian from the very beginning, but we are replacing the second column with a 0f. And so we calculate these things. So it's just a matter of just putting into the formula, into these 3 formulas, and then calculate the w, w1, w2. And now once we do have that, this is where the fun part starts. So in order to calculate the particular solution to the original differential equation, we are going to assume that the particular solution is of this format. Notice that this is the same y1 and y2 that you get from your complementary solution. Okay, but now what we're saying is that we're going to assume that the constant c1 and c2 are no longer constant, but they are functions u1 and u2. And now we're going to say how to calculate those u1 and u2. Well, we have formulas here in the very bottom. And the formulas are not actually of the u1 and the u2, but they are of the derivatives. All right, so 4 steps. I know it's very fast, but I'm going to write down the steps as we go. And we're going to use this, and then we're going to get the general solution to the problem. All right, so here's the differential equation. And so what is the first step? The first step is we want to get the y double prime by itself. And so we're going to divide by a everywhere. And then in this case, we're going to divide by 2 everywhere. And so we get y double prime minus 6y prime plus 9y is equal to x plus 1 e to the 3x. And now we do need to identify a few things here, okay? So we want to identify that the f is equal to this x plus 1 e to the 3x. Okay, so we need to identify that. And then we could identify the p and the q, which here's the p and here's the q function. All right, so now step number 2 says we want to look at the homogeneous equation, and then we want to find the complementary solution to that, or the solution to that. And so what we're going to do is we'll look at the homogeneous equation, which in this case turns out to be y double prime minus 6y prime plus 9y is equal to 0. And so how do you solve this homogeneous equation? Well, this is something that we can do. So we eventually get to the auxiliary equation, which is m squared minus 6m plus 9 is equal to 0. You get your 2 factors, which in this case you can factor with this m minus 3 and n minus 3 repeated twice. And so your factors are m is equal to 3, and then it's repeated twice. Okay, so I just write it down once. And so what does that mean about your complementary solution? That means that the complementary solution, and I'll write this in gold, so that means that the complementary solution is going to be C1 times e to the 3x plus C2 e to the 3x. But since this is repeated twice, and let me actually write down the 3 again. So 3 comma 3 is repeated twice. That means that your second solution is going to have an extra x on it. To get that, you use the reduction of order, if you remember. All right, so we found the complementary solution now. All right, so that's step 2. All right, so this basically is a review of what we have done already. Now we're gonna get to the step 3. So now that we have the complementary solution, we also got the y1 function and the y2 function separately, okay? So in order to calculate the W information, we had to find the derivative of the y1 and the y2. So derivative of e to the 3x is 3e to the 3x. The derivative of the other one, the y2, we have to use the product rule. So it's going to be x e to the 3x multiplied by 3 plus e to the 3x, right? So we have to use the product rule for the derivative of the y2. All right, so now that we have that, now we're going to calculate this W information. And so these are the W original one. This is going to be the Wronskian, which is y1, y2 prime minus y2, y1 prime. So all we have to do is just plug in the information. So y1 is e to the 3x, y2 prime is this product rule that we just found, 3x, e to the 3x plus e to the 3x. So that's the first piece only, minus the W2, which is x e to the 3x, multiplied by y1 prime, which is multiplied by 3e to the 3x. All right, so I'm going to combine, I'm going to distribute first with the parentheses stuff, and then I get 3x e to the 6x plus e to the 6x minus 3x e to the 6x. So the 3x e to the 6x cancels out. And let me just write that in red just to make sure that we are on the same page. And so we are only left over with e to the 6x. So that's for the W function. Now we want to calculate the W1 function. And in the W1 function, we have a formula. And then this formula is very simple. We just write this down. And then this turns out to be minus y2 multiplied by the f. Okay. So that's the formula. And that means that we just plug in the information. So minus the y2, which is negative x e to the 3x multiplied by the f function. And then the f function is, and let me write down the f function here in the very beginning because it is not actually this. The f function is actually x plus 1 e raised to the 3x. Okay, that's the actual f function. And so we do have to be careful on what the f function here is because otherwise we will get the wrong answer. So the f function is x plus 1 e to the 3x. You simplify this, and then this turns out to be negative x e to the 3x, and then multiplied by x plus 1. I'm going to make a simplification here. So this is actually 6x. The coefficients, the powers add up, and so it gives you 6x for the exponential. All right, so that's the middle W1. So that's this function. And now we have one more thing to calculate here. So I'll put this in blue. So we need to calculate the W2. And if you do the calculation here, this is going to be y1 multiplied by the f. Okay, y1 multiplied by the f. And again, so all you do is just plug in the information, which in this case is going to be e to the 3x. The f function is x plus 1 multiplied by e to the 3x. And so in this case, this gives you x plus 1 e to the 6x. All right, so that's your W2 function. All right, so 3 W functions, and then we're going to use that information to be able to calculate the particular solution, and then that's the next step, right? So right now, this is just calculating the information that we're going to use. And we got this information by looking at the information from the complementary solution. All right, so I rewrote the functions here in the top. Okay, so the W function is there, the W2 function is there, and also the W1 function is given here, okay, just typed up. All right, so now for the step number 4, we want to calculate the particular solution. And so what we do is we are going to assume that the particular solution is of this format, where it is y1 and y2 again, but we need to calculate this u1 and the u2 functions. All right, so we do have formulas for those, but now the tricky part is that we are not calculating the u1, u2 directly, we're calculating the derivatives, and so let's do the calculation here. So the u1 prime is the w1 function, which is negative x plus 1 e to the 6x divided by the w function, which is the Wronskian, which is e to the 6x. So now this is the e to the 6x cancel out. So that means the u1 prime is equal to just simply negative x squared minus x. Okay, so that's the u1 prime. But now what we want to find is the u1 itself. Okay, so u1 is going to be equal to the integral of that. So it's going to be negative x to the 3 divided by 3 minus x squared divided by 2. And you could put in a plus c if you wanted to, but let's just write it out here without the constant. Okay, we usually don't put in the constant whenever we do the variation parameter. So that's the u1 function, and then we do a similar step for the u2 function. And so the u2 prime function is going to be the w2, which just copy and paste, x plus 1 e to the 6x divided by the w function, which is e to the 6x. Now the e to the 6x cancels out, so you get the u2 prime is equal to simply x plus 1. And so what that means is that the u2 function is going to be equal to x squared divided by 2 plus x, and technically plus 1, but we only write this down. All right, so now this question was asking us to find the particular solution, and so we have these formulas for the u1 and the u2, but we had to do an extra integration here. But now we have to recall what the complementary solution was. What was the complementary solution from the very beginning? So let me put it here in the very top. This was c1e to the 3x plus c2xe to the 3x. All right, so we're going to use the complementary solution and then to put together with the u functions that we have, and we're going to use this formula that's given to us. We assume that the solution was this red format. All right, so now that means is that the particular solution is going to be, let me write it out here. So yp is equal to u1 y1 plus u2 y2. All right, so that's the format, and those are u functions. So u1 is this guy, so negative x to the 3 divided by 3 minus x squared divided by 2, and then y1 is e to the 3x. Now add the u1 function, that's going to be x squared divided by 2 plus x, and multiply by the y2, which is an extra x, so you have e to the 3x. All right, and yes, you could simplify a few things here and there, but we're just going to write this down as it is in this way. So this is the particular solution for the given differential equation. All right, so now we want to make a conclusion, okay? So in the very beginning, we found the complementary solution. So in the very beginning, we found the complementary solution by looking at the homogeneous equation. And then the W information gave us the U information, which gave us the particular solution, okay? To get the particular solution, we had to do a little bit of backtracking. So we had to find the W functions, then we have to find the U functions, and then we can create WP function. All right, so now the conclusion is the following. So we have calculated the complementary solution again. So this is information coming from the complementary solution, and then this is information coming from the particular solution. So for the particular solution, you use both the y1, y2, and the u1 and the u2. Now what I'm trying to say here is that we want to find the general solution to the differential equation. And so you remember that the general solution is of the following format. The general solution is going to be the complementary solution plus the particular solution. So that's the general solution. So now we're going to write this down, and so it's going to be a little bit lengthy, but so write down the complementary solution. Now we need to write down the particular solution, and so if you remember, so I'm just copying down the particular solution. And there is an extra x here. So let me put that in red to make sure that we are on the same page. And yep, that's it. So that is your particular solution to the problem. Okay. So it's the combination of the complementary solution with the particular solution that we found previously. And step number 1 and 2 gave us that was us finding the complementary solution. And then the other steps, we had to find the W information and then the U information. And then we can create the particular solution, which is the red part, right? And it's true, again, we can simplify some things here, but the point here is that I want to show you the method for finding the general solution. All right, so that's one example. Now I want to give you another example where this is actually giving you information from the very beginning. And what that means is the following. So here is the differential equation, and then they are telling you that the complementary solution is already given to you, and they give you the formula for it. Okay, so they tell you, hey, here is the complementary solution. So you don't have to do, technically you don't have to do step 1 and 2, which I have here. So technically the step number 1 is divide by A, and step number 2 is find the complementary solution, but you already have the complementary solution. But it is very important to know that step number 1 is actually very important, because when you divide by A, you do, in the very beginning, this is not your f function that you're going to use in your method. When you divide by A, you get the following. So y double prime minus 2x divided by x squared plus 1 y prime plus 2 divided by x squared plus 1 y is equal to 6, and this is going to be x squared plus 1 only. There's no square on the parentheses. So now this guy is your f function. So your f function is simply 6 x squared plus 6. All right, so that is the important part from step 1, which is going to appear later on. So now let's go into the step number 3. Okay, so the complementary solution was given to you already. So that means that you already know the y1 and the y2 functions. They gave you that information in the problem. And so in order to calculate the double information, we need to find the derivative of these y functions. So the derivative of x is 1. The derivative of x squared minus 1 is 2x. And so now, what is the f function? Before we calculate the w information, we need to find the f that we're going to work with. And so if you remember, this is 6x squared plus 6. 6x squared plus 6 is your f function. That is very important to know how to get before you can actually calculate the w information. All right, so now we have all the information that we need to be able to calculate this. Okay, so the formula for this w guy is going to be y1 y2 prime minus y2 y1 prime. So all we have to do is just plug in the information for the y. So this is going to be 2x squared minus, and then cross multiply. So that will give you a x squared plus 1. After you do the algebra, you get x squared plus 1. All right, so now what does that give you? So that gives you a x squared plus 1 for the w. All right, so that's w. So now w1, let me put that in purple. W1 is going to be negative w2 multiplied by the f. And so if you put in the information, so this is going to give us what? So this is going to give us negative x squared minus 1 multiplied by the f, which I'm going to write it out as it was before. So 6 and then x squared plus 1. Okay. So let me just write it out as negative 6 x squared minus 1 x squared plus 1. All right. That's the w1. So now let's calculate one more thing, which is the w2. And the formula for this guy is y1 multiplied by f. And so y1 is equal to x. And then the f, again, I'm going to write it down as 6 and then x squared plus 1. All right, so there's nothing you can do here. Just rewrite it as 6x and then x squared plus 1. All right, so you need these 3 pieces of information, the w information, before you can actually calculate the u information, which the u information helps you calculate the particular solution. All right, so I'm going to rewrite this or type this up for you on the very top here. So that's the w and w2, and then also the w1 in the middle. All right, so now to find the particular solution to the differential equation, we are going to assume that the particular solution has the following format. We're going to say that it essentially looks like the complementary solution, except that we now have u1 and u2 instead of just numbers. And then we want to calculate those functions u1 and u2, and we have formulas for those guys. And so all we do is just plug in the information. And so let's calculate the u1 prime. So according to the information, the w1 is negative 6 x squared plus 1 x squared minus 1 divided by the w information, which is x squared plus 1. And so that means that the u1 prime is equal to what? Negative 6x squared plus 6 after you distribute. So negative 6x squared plus 6. So that's the derivative of u1, but what we care about is the actual u1 itself. That means that we have to integrate this. So that's going to be negative x to the 3, and then 6 divided by 3 is a 2. 6 divided by 3 is a 2, and then plus 6x. So that's the u1 function. Now we calculate the u2 function, but the formula is given to us to calculate the u2 prime. And so u2 prime is equal to w2, a little bit more lengthy, but we just copy and paste. So x squared plus 1, and then x squared minus 1, divide the whole thing by the w, which is x squared plus 1. Oh, I wrote the wrong thing here. Okay, so this is not u2. So let me try this again. So the u2 prime, we write down the w2. So this is 6x and then x squared plus 1 divided by x squared plus 1. So this is actually easier. So u2 prime is equal to just simply 6x. u2 prime is just simply 6x. And so what that means is that we need to integrate to get the u2 function, which becomes a x to the second power. 6 divided by 2. 6 divided by 2 is a 3. All right, so now that we have this information, we can write down the particular solution. Okay, remember, we want to find the particular solution, but in order to find the particular solution, we have this specific format that we assume, but we need to use the W information to get the U1 and the U2. And so the particular solution is going to be the combination of the U1, so minus 2x3 plus 6x multiplied by the y, multiplied by the y1 function. And what was the y1 function? Okay, so this is a different problem. So let me recall what the y1 function was. Y1 function was just x, and then the y2 function was x squared minus 1. All right, so I'm going to multiply by x here. And now I need to add my u2 function, which is 3x squared. And I'll multiply by the y2 function, and that is x squared minus 1. Remember, the gold information was given to us in the very beginning of the problem. All right, so that is the particular solution to the differential equation. So notice the two things that we now have. We have the complementary solution, which was given to us from the very beginning. And then we also have, we created the particular solution. And yes, we had a big assumption to make here in the very beginning. We assumed that the particular solution was in this format. And we have these formulas that at the moment they're coming out of nowhere, but we're going to explain that in a different video. So we have the particular solution. So now what I want to say is I want to summarize all the information that we have. Okay, so let me give you the outline again. So this is the particular solution information in gold. And then to find the particular solution, we had to calculate this U information. So the U information is not just the U1 and the U2. The particular solution was a combination of the Y's and the U's. And now we want to find the general solution, okay? The general solution to the ODE. And remember that the general solution for a non-homogeneous differential equation is going to be the complementary solution plus the particular solution. All right, so now this is going to be a little lengthy to write down. So the complementary solution is going to be C1x plus C2x squared minus 1. And now this particular solution is going to be this very lengthy formula. And actually, it does simplify it by a lot, but I won't simplify it. I want to just show you the big picture idea. So this is U1 multiplied by the Y1 plus the U2, which is 3x squared, multiplied by the Y1, which is x squared minus 1. This particular solution can be simplified by a lot, but I'll let you check that out. And that is the general solution to the differential equation. All right, so do you see that we can actually deal with the more complicated functions now, more complicated differential equations, because now we have functions in front of the y prime, y double prime. All right, so that's what I want to say for today. I hope that this is helpful, and I'll see you next time. And the next time we'll do some theory and plus some other examples.